Hi guys, in this video we're going to find the derivative of ln x. I'm going to expect you know your log rules. If you don't, look up a video on YouTube, go through it. We're going to be using all of the log rules pretty much today, so really important you have an understanding of them. We're also going to use the definition of e, but I'll show you that. Not many people know this definition, but we'll go through it. So first of all, we're going to use the division rule. If I've got two logarithms minus each other, it becomes a division. So we're going to have lim as h approaches 0 of what is going to be ln of x plus h over x. Now, I can also bring this 1 over h sort of out to the side, so it's 1 over h. Be careful, this is not inside the logarithm, it's a 1 over h outside. I'm going to quickly have a look over here at this x plus h over h, over x I mean. Well, if I break this up, it becomes x over x plus h over x, which is the same as 1 plus h over x, and that's how I'm going to write it in future lines. We then get the lim as h approaches 0. Now if I bring this 1 over h to the front, like so, what I'm going to do is I'm going to times by x over x. Now x over x is just the same as 1, and if I change this order, so that we have x over x times 1 over h, what I can do is sort of just use a bit of multiplication rules, and I can change the order, so it's going to be 1 over x times x over h multiplied by ln of, well, we've got this new form, 1 plus h over x. I can then use the power rule. If I've got a coefficient of a logarithm, it's the same as bringing it to the power. So it's going to be the same as lim as h approaches 0 of 1 over x times ln, and this is the tricky part, 1 plus h over x all to the x over h. You're probably like, why on earth did I do this? Why did I bring this x over x out? Well, what I can say is, I can say that n equals x over h. I can then say that 1 over n is equal to h over x. And I'm going to correspond with these arrows. You can clearly see that I've got n and I've got 1 over n. So I can replace that in. I can have 1 over x ln 1 plus 1 over n all to the power of n. But I've got to change my limit. I no longer have h's, I have n's. So if h is approaching 0, I can put that in. It's going to be approaching infinity for n. So we can say lim as n approaches infinity, like so. Now, in case you didn't know it, inside here is actually the definition of e. So I'm basically saying 1 plus 1 over n to the n. That's my definition of e. If you want to try this, get your calculator out, put a really large value of n in. It should come around about e. You should get it about 3 or so decimal places if you're doing it to a million. Anyway, why is that important? Well, if I have e inside of a ln, that's just 1. So this whole thing is just 1, which means when I apply my limit, I'm just left with 1 over x. And that's our derivative. Thanks for watching. In the next video, we'll find the derivative of e to the x.